Hello everyone and welcome once again to our latest installment of using the CATIA software. As we are learning various tools in CATIA, today we are going to learn which are the different profiles that can be created. In our last video we have seen how to create a pentagon. In today's video we are going to focus on an hexagon and an octagon. First of all, we will learn about how to draw a hexagon. Hexagon is something that has 7 sides, 7 equivalent sides. It is the next version to hexagon. It is in the series of pentagon and hexagon. So today we will focus on drawing a hexagon. So to do the usual process, we simply open up one of the planes and we will draw the hexagon. So I will select plane XY and then I will choose the position sketcher option and then press OK. So here it is. We have opened up the plane. It is first of all, I would urge you to draw a particular drawing having 7 sides. Then we will constrain it and then we will convert it into a hexagon. So let us first of all draw a 7-sided figure. So here it is. We will start off from here. We will choose the profile tool, by the way. The blue line indicates that it is either horizontal or vertical. In this case it is horizontal. Try to keep the lengths similar to one another. Here it is. I won't keep it, just trying to make sure that we keep it really close enough to a 7-figure mark. So as we can see, we have drawn a particular figure which is not constrained. It doesn't look like a hexagon by any means. Again, a reminder, hexagon which has 7 sides. So let us first of all count the number of lines and sides that this figure has. This is number 1, number 2, number 3, number 4, number 5, number 6 and number 7. So this figure has 7 number of sides, but it isn't constrained, so we can't call it as a hexagon. It has to have equal lengths as well. So make sure that you while drawing this system, you make sure that you actually keep it close enough with the constraints. So here it is. It is just almost of this length, this length. They almost are of same length. Actually they aren't of the same length, but try to keep it of the same length. We will then choose the dimension constraint option by double clicking it, so we don't have to go back and choose the option again and again. So I will choose the first line. It becomes blue and white, so click on it. Here comes the dimension. Then we have to double click on the dimension, as we are choosing for 50 mm side, so let us press 50 and then press OK. So then after pressing it, we shall now move to the second side. We will once again choose the line. It becomes red after dimensioning, 35.197, double clicking on it, and we will then press 50 and press enter. It becomes wavered, this figure, but as we start constraining it, it will come into shape. Again, we will give this dimension, double click on it, and then we will give it as 50. Next dimension, again we will give every single side a length of 50 mm. Now our next one, again we will make it 50. You simply have to double click on the dimension that we get, so you don't have to panic. Just simply double clicking on it and either pressing OK, or you can press enter button on your keyboard, and the final dimension, it will also be 50. So here it is. We have created a geometrical figure which has all its sides 50 mm, but still it isn't hexagon, only because it doesn't have total constraints. Here we can see that this figure isn't symmetry, so here we can guess that it still has been lacking some of the dimensions. So what could it be? If you have gone through our previous videos of a pentagon, you might know that we have to constrain by giving angles, and we know that for a pentagon we divided 360 degree by 5 and we got the external angle. The angle between the two consecutive sides of the hectagon from external side. In case of a hectagon, we simply have to divide it by 7. So 360 divided by 7. So it may well appear that it can be an irrational number. So it can be a rational number as well. So it isn't a whole number. So in that very particular case, we don't have to give it in the points. We simply can give the ratio of the dimensions, and the dimensions could arrive. So I will show how is it done. First of all, choose the line that is the horizontal line, and then the second line which is inclined. I will press on this line, and then I will press on this line, and the dimensions arrive. So here it is on external side, and if I get the cursor on the internal side, the internal dimensions arrive. So I will keep it on the external. Now here you can see this 50.135. We will double click on it, on that angle, and then we will have it. So since we are having a hectagon, it is 7 sides, so divide 360 by 7. So I will just simply write it in this manner. Keep a close eye. 360. Then I will press the forward slash button, which also represents divide sign, and then we will press 7 because it is divided by 7, and then I will press either OK or enter, and here it is. This angle is created. Similarly, for this side as well, it is the same position. So I will double click on it, and then we have either the internal angle or the external angle. Try to keep it on an external angle. Double click, and then press 360 forward slash, or you can say it as a divide sign, and then divide it by pressing number 7. Click on OK or enter, and here it is. We get it. Now still it isn't a constraint because we have only constrained 3 sides here. We will constrain the 4th side, and we shall have it. There it is. It is 53 point somewhat. Double clicking on it, and then I will press 360 forward slash or divide by 7, and then pressing OK. Then similarly for this 2 sides as well, the angle should be 360 forward slash 7, and then we will have it. Here we can now see that hectagon is created. It has equal side of lengths. We don't have to define every single dimension, because if I actually do it, it will be over constrained. Here we can see all the dimensions become violet only because they are over constrained. We don't have to give the final dimension. Just keep an eye that the dimensions might just change at times, so keeping in mind. So here we can see everything is perfect. It is a hectagon with 7 sides, 7 equal sides, similar to hexagon. We already have that hexagon option present here, so we don't have to learn how to draw a hexagon. Yesterday we learned how to draw a pentagon, so we have learned now how to draw a hectagon. If we simply want to bring it into the center, what we will do is we will draw a line perpendicular from the base, and here in this particular manner the figure becomes violet because it is over constrained. Similarly, I will draw a perpendicular to this line as well. These 2 lines where they intersect is going to be the center, so to mark the center we will use the points command, which is already present here, and then both the lines become red once I am at the center of both these lines. So I will click on that point, and a point will be created. It is slightly visible here, and then 2 lines which will are of no use, we will delete those 2 lines once the center is marked, because that will create an open profile. So keep in mind that we don't need an open profile. Remember, through every single point we have 2 lines passing through it, and it actually compromises some area as well. So our geometry is well and truly correct. Then we will define this point as well with a dimension. We'll define it in this manner. You can define it with any of the 2 points. There it is. So now that the point is also constrained, if I just move this point, the entire geometry moves as well, the entire hectagon moves as well. Previously, if I don't give this dimension, only the point moves and not the hectagon. I'll show you. If we delete this and if I try to move this point, only the point moves and not the hectagon. So in order to make sure that it has a direct relationship, we will give it in dimension with at least 2 sides. Here it is. And now if I move the point, the entire geometry moves as well. Now if we want to bring this figure at the origin, we simply have to click on the center of the hectagon and then clicking on the origin by pressing the control button so that the 2 points get selected, and then we will go in the geometrical constraints option where we have coincide option, and once we click on coincide, the entire geometry comes at the center as well. So here it is, a hectagon has been drawn. We have now learned how to mark the center. Once the center is marked, how to bring it to the origin as well. Similarly, we will be focusing on some other figures as well in our future videos. Mainly our next focus will be on an octagon and how to use an octagon as well. For now, we are running out of time. Thanks for joining. Join us again next time. Until next time, goodbye.